All right, I'm going to walk through this lovely review sheet for quiz on our Unit 3. Some fun stuff here in applying derivatives to graphs. So let's go for it. All right, number 1, multiple choice. Find all critical numbers for this function. Okay, critical numbers are where, whoopsies, either f prime of x is 0 or f prime of x is undefined. But this is a nice polynomial function, so I'm sure we're not going to have to deal with this undefined in this problem. Now, we need to find the derivative of f of x, but we don't really want to multiply that all out. That would be too much work to do. So let's see if we can use the product and chain rule. It looks like we've got the product of two functions, right? X plus 2 to the fourth times x minus 1 cubed. So the derivative should be the first times the derivative of the second. So f prime of x should be the first function, which is going to be x plus 2 to the fourth, times the derivative of the second function, which should be 3 times x minus 1 squared, times the derivative of x minus 1, which is the inner function. But of course, that's just 1, so the chain rule is inconsequential in this example. So that's the first derivative of the second plus the second times the derivative of the first. And the first function is x plus 2 to the fourth. So that's going to be 4 times x plus 2 cubed, again times 1, which is the derivative of x plus 2. So let's simplify this a bit. Let's see, we're going to have 3 times x plus 2 to the fourth times x minus 1 squared plus x minus 1, or 4 rather, times x minus 1 cubed times x plus 2 cubed. So that's f prime of x. So we want to see if we can do some creative factoring here to simplify this down. So what I notice is that both of our terms, right, if this whole thing here is term 1 and this whole thing here is term 2, both of them have an x plus 2 cubed, at least, and an x minus 1 squared. So I'm going to factor that out because remember, I want to set this equal to 0. And setting equal to 0, it's good to factor things out. So f prime of x would then be equal to x plus 2 all cubed times x minus 1 all squared times the stuff that's left, which would be, in the case of the first term, 3 times x plus 2. And in the case of the second term, 4 times x minus 1. Okay, so I essentially factored out what they have in common, which is an x plus 2 cubed and an x minus 1 squared. So now I'm going to simplify the parentheses, the parentheses right here. Okay, and I'm going to get f prime of x is equal to x plus 2 cubed times x minus 1 squared times, now I'm going to do some of this simplification in my head. I've got a 3x plus 6, right? Actually, I'm not going to do it in my head. I could, but I'm just going to write it out here. 3x plus 6 is what that becomes, and this is 4x minus 4. So if I combine those two things, I should get 7x plus 2. Okay, so now f prime is factored neatly, and when it's factored neatly, it's easy to see, easier at least, to see what the zeros would be. So I'm going to set this thing equal to 0 now, and I should be able to see now, because of the zero product property, that the zeros of f prime are x equals -2, which comes from the x plus 2 cubed, x equals 1, which comes from the x minus 1 squared, and x equals -2/7, which comes from the 7x plus 2. Essentially what I'm doing is I'm setting each piece equal to 0. That's the zero product property, right? But because I've done this many, many times, I don't really need to show all those steps there. But if you solve those three equations, you're going to get -2, 1, and -2/7. Okay? And that is going to give us our solution, which is B. -2, -2/7, and 1. Okay, so not a hard problem conceptually because we just know that the critical numbers are where the derivative is 0 undefined and there are no undefined points, but it is a little bit of a challenging problem algebraically, which is typically what happens in calculus classes. Okay, I wish I could get rid of this sidebar, but I'm not smart enough to figure out how. So, I just figured it out. I guess I am smart enough to figure it out. Cool. Okay, let's look at 2. I wonder if I can select this thing and then move it. Wow, incredible technology. Okay, this is what we call the take a breath moment of this video. Okay, given the graph of f prime, find all the critical values. Okay, it probably should say find all the critical values of f of x. I'm assuming that's what it means because we could technically find critical values for f prime, but we're going to find critical values of f, and critical values of f should be where f prime equals 0 or where f prime is undefined. So we're looking at this graph and trying to figure out where is it 0 or where is it undefined? Well, it's 0 right there and right there and right there. So it looks like there's 3 places where f prime is 0. I don't see any places where f prime is undefined, right? It looks like it's well defined on this whole interval from -5 to 9. So it looks like my critical points, critical values of f, if that's what the question is asking, would be where my derivative is 0. That would be at x equals -3, x equals 1, and x equals 7. Since, if I wanted to justify my answer, which I probably wouldn't on a problem like this, but since f prime of -3 equals f prime of 1 equals f prime of 7, they all equal 0. So all those are 0, and that's the definition of a critical point. Again, here, this derivative that we're looking at is always undefined, is always defined, so I don't need to worry about the undefined. Okay, another multiple choice question. They're asking me to find the maximum value on a closed interval. Okay, anytime you see closed interval, you should be thinking the closed interval test, or called the candidates test, which says the maximum or minimum value on a closed interval has to be at one of the endpoints or possibly a critical point in between. So your first step is to find the critical points. So let's find the derivative, which is simply 6x squared minus 30x plus 36, and let's set it equal to 0. 6x squared minus 30x plus 36 equals 0. Divide everything by 6, and we get x squared minus 5x plus 6 equals 0. We don't really need to factor out the 6 because it's a constant. We can just divide the equation by 6. That's the division property of equality. Now we can probably factor this. Two numbers that multiply to 6 add to -5 are -3 and -2. So that means that the critical points of f are x equals 3 and x equals 2. okay? Because that's where f prime is 0. Well, it turns out that both of those are on the interval we're interested in. So now we need to compare f of 0, f of 2, f of 3, and f of 4 to see which one is the biggest. Remember, this is not the first derivative test. We're not finding relative extrema. We're finding the absolute maximum value on a closed interval, which has to be at one of the endpoints or at a critical point on the interval. Well, f of 0 is 0. F of 2, now this is going to cause me to have to do some mental math. F of 2 is, let's see, 2 to the fourth, 16 minus 15 times 4 is minus 60, plus 36 times 2 is 72. So 72, I think, so this is going to be 88 minus 60, which is 18, I think. No, 28. Okay. F of 3, oh, good night. Oof. 3 cubed is 27 times 2 is 54. Then minus 15 times 9. I mean, this is a nightmare here. I got to get my calculator. Let's see if we can do this. So 15 times 9 is minus 135. And then 36 times 3 is 108. So that is, sorry, this is going to be really slow and boring, but such is life. You can skip it if you want to. That's 27, I think. And then f of 4 would be 128 minus 240 plus 36 times 4, which is 144, which equals 144 plus 128 minus 240 is 32. Okay, so comparing all of those values, it looks like my maximum value is 32, and my minimum value on that interval would be 0. Okay, so again, on a closed interval, you need to find your critical points on the closed interval and then compare the original function values at the endpoints and the critical points to see which one is the largest in this case or the smallest. Okay, same thing for number 4, right? Absolute max and absolute min on this closed interval. Okay, and of course the extreme value theorem tells me that a continuous function on the closed interval will have a maximum and a minimum value. And 2x minus 3x to the 2/3 is definitely a continuous function on this interval. So let's find our critical points first by finding f prime of x. F prime of x is 2 minus 3. Okay, then 2/3 x to the negative 1/3, right? I don't need to use the product rule here because I'm just multiplying by 3, which is a constant. So don't do that. So f prime of x is now equal to 2 minus 2 over x to the 1/3. It's good to have this as a single fraction. So I'm going to multiply the 2 by x to the 1/3 over x to the 1/3 to get a common denominator. And that's going to give me 2x to the 1/3 minus 2 divided by x to the 1/3. If I want, I can rewrite that with a cubed root. And I do want to. So I'm going to say 2 cubed root x minus 2 divided by the cubed root of x. So I'm looking for critical points, which would be if the derivative is 0 or undefined. This is 0 if the numerator is 0, which would mean 2 cubed root x minus 2 equals 0, which means the cubed root x would have to equal 1. And therefore, if I cube both sides, x would have to equal 1. And this is where, of course, f prime or where f prime is 0. So we know f prime of 1 is 0. But also at x equals 0, the derivative is undefined. So those would be my two critical points, x equals 1 and x equals 0. So now I need to compare f of negative 1, which is an endpoint, f of 0, which is a critical point, f of 1, which is a critical point, and f of 3, which is my other endpoint. Whichever one is the biggest is my max. Whichever one is the smallest is my min. Okay, so this is now just algebra, of course. Let's see, f of -1 is -2 minus 3 times -1 to the 2/3. Now, -1 to the 2/3 is the cubed root of -1 squared, and the cubed root of -1 is -1. When you square it, you get 1. So that's going to be -2 minus 3, which is -5. Plug in 0, I somewhat obviously get 0. Plug in 1, I get 2 minus 3, which is -1. If I plug in 3, I get 6 minus 3 times 3 to the 2/3. Now, I need to figure out what that is. So I'm going to do my handy dandy cubed root 3 on my calculator and then square it. So let's see, I'm going to square that and get about 2 point something, multiply it by 3, then subtract that from 6. I get something like -0.24, I think, if I did that correctly. Okay, well, it looks like um, the absolute max of f of x on -1, 3 is, well, 0. Is 0 and occurs at x equals 0, while the absolute min of f of x on the interval -1, 3 is, I don't really like this, occurs is, I'm going to say f of -1 equals -5. Okay, so that tells me that it's located at x equals -1 and that the y value is -5 rather. So it looks like those are my absolute max and min on this interval. Oh boy, even one more. Locate the absolute extreme of this function over this interval. Okay, let's find our critical points. F prime of x is equal to -3 sine x. Let's set it equal to 0. 0 equals -3 sine x. Divide by -3, and you still get 0 equals sine x. On the interval pi halves to 3 pi halves, the solution to this equation is x equals pi. Now, by the way, 3 cosine x, I should already know what's going on for 3 cosine x. It starts up here, comes down like this. It starts at 3. Pi halves is, let's see, this is pi, so here's pi halves, and here's 3 pi halves. So I'm probably going to expect that my maximums are going to happen at the endpoints, and the absolute minimum is going to happen in the middle. So let's see what happens. I need to check f of pi halves. I need to check f of pi. I need to check f of 3 pi halves. Okay, endpoints, critical points in the interval. F of pi halves is 0, right? Because cosine of pi halves is 0. Yes. F of pi is -3 because cosine of pi is -1, and I'm multiplying by 3. This is tracking with the graph that I drew over here. And f of 3 pi halves is again 0. So f of x reaches its max value of 0 at x equals pi halves and x equals 3 pi halves. And its min value at x equals pi on the interval pi halves, 3 pi halves. Find the difference between the absolute maximum and absolute minimum values of this function on this interval. Okay, well, again, all I need to do is find the absolute max and absolute min using the closed interval test. Okay, so if you're getting bored of these, of course, you can just skip ahead. Do whatever you want. Delete the video. I don't care. Find the difference between the absolute max. Okay, well, we got to find our critical points, of course. F prime of x is equal to, oh my goodness, 3 times x. This is 3 times x to the 1/3 minus 4x, right? That's f of x. Okay, so to find the derivative, I need to use the power rule, the difference rule, coefficient rule, etc. Multiply by 1/3, I get x to the negative 2/3 minus 4, okay? And that is equal to 1 over x to the 2/3 minus 4. But I'm going to multiply this by x to the 2/3 over x to the 2/3 so that I can get it as one fraction. That's going to be 1 minus 4x to the 2/3 divided by x to the 2/3. That is f prime of x. Okay, so this function, f prime, is 0. Remember, I'm finding my critical points, so where the derivative is 0 undefined, where 1 minus 4x to the 2/3 equals 0, which means x to the 2/3 would need to equal 1/4. Now, in order to get rid of the 2/3, I need to raise both sides to the 3/2. Okay, but also the tricky thing about this is when you're raising something to the 3/2, you're actually taking a square root. So remember, when you take a square root of an equation, you have to get a positive and a negative solution. So essentially what I'm going to get is x equals the square root of 1/4 cubed, but it can be either positive or negative the square root. So it should be x equals 1/2 cubed or x equals negative 1/2 cubed. And so I get either x equals 1/8 or x equals negative 1/8. Now, this is not on my interval, so I'm not going to worry about it. But technically, that is a critical point of this function. It looks like this function also has a critical point at x equals 0, because that's where the derivative would be undefined. But since that's an endpoint, it doesn't really matter. So now I need to check f of 0, f of 1/8, and f of 1. And I'm going to find which one is the max and min, and then I'm going to find the difference between them. Okay, well, f of 0 is pretty clearly 0. F of 1 is somewhat obviously negative 1. F of 1/8, well, the cube root of 1/8 is 1/2. So that is going to be 3/2 minus 4/8, which is 3/2 minus 1/2, which is 1. So now I can see that the absolute max is 1 and the absolute min is negative 1. So the difference between them is 2. Okay, let's transition to something else. Suppose f of x is differentiable everywhere. Lovely. Okay, that's important. So mean value theorem applies. And f of negative 2 equals negative 5, and f prime of x is less than or equal to 5 for all values of x. Using the mean value theorem, what is the largest possible value of f of 8? Okay, so the largest the derivative can be is 5. Okay, at any point on this interval. Well, what interval are we looking at? We're looking at the interval from negative 2 to 8. So say we have some graph here. Here's x equals negative 2, and here's x equals 8. And basically what we're saying is nowhere on this interval, is the slope of the tangent line more than 5. So none of these tangent lines can have a slope greater than 5, which means the largest possible um, average slope could be 5, right? Because if it were more than 5, the mean value theorem tells us there has to be at least one place where it would be more than 5. So we need to make sure that whatever this value is gives us an average slope that is 5 or less. So this is kind of I would say, a good question to really test your understanding of the mean value theorem. So let's see here. The average rate of change would be f of 8 minus f of negative 2 divided by 8 minus negative 2. And that is equal to f of 8 plus 5, right? Because f of negative 2 is negative 5, divided by 10. Okay, and basically what I know is this right here, this average rate of change has to be less than or equal to 5. There's no way it can be bigger than 5, because if it were bigger than 5, then this thing would be false. There'd have to be at least one place where f prime was greater than 5. So I can actually just solve this equation for f of 8 and get f of 8 plus 5 has to be less than or equal to 50. So f of 8 has to be less than or equal to 45. Boom. That's the largest value that I could have. And it still be true that f prime is less than or equal to 5 for all values of x.